Hi guys, in this video we're going to go over power. We'll define it and then do some calculations to calculate various scenarios in which you can be asked to calculate the power. So what is the definition of power? Power is defined as the rate at which work is done or energy is expended. The main definition is shown here. I'll just circle it in green. From the definition we get this formula, the rate at which work is done. It can also be proven that power is also equal to the average power is equal to force times average velocity. This is a proof that you don't really need to know, so I'm not going to go derive it in this video. We'll just do a quick question or a quick example on how to calculate power. So how does the question go? It says a forklift lifts a crate of mass 200 kg at a constant velocity to a height of 10 meters over a period of time of 5 seconds. Forklift then holds the crate in place for 20 seconds. What are we required to do? We're required to calculate how much power the forklift exerts in lifting the crate and how much power the forklift exerts holding the crate. So we need to calculate power in two situations. Right. So let's write down what we're given first, and then we'll try and calculate the power in the two cases. Okay, so we're given mass is equal to 200 kgs. We've got height is equal to 10 meters, and the time is equal to time 1 is equal to 5 seconds, and time 2 when it's stationary is equal to 20 seconds. Right. So we have mass, height, and time. So height can also be thought of in this case as displacement. That's the amount of movement. It can be changing x or changing y. X should be actually changing y, but we'll just call it changing x. So we know that power can be one of two things. Power can be equal to work over the change in time, or the rate at which work is done. It can also be equal to force times velocity. So force times velocity is also equal to force is the force of gravity. Velocity is the rate of displacement, rate of change of displacement. So we already have mass, we have gravity, we have displacement, and we have the time. So now we just have to substitute. That's all we had. All I did was just rewrite the formula a few times, and now we found the one that we can use. So we use the n formula over here. Depending on your situation, you could use any formula to determine power. Any of these formulas to determine power. So we can say that power is equal to mg displacement over time. We're doing the first case first. So mass is equal to 200 kgs, gravity is 9.8, displacement is 10 meters, and the time it takes to move upwards is 5. Therefore, the power expended, or work done, this is the power expended actually, will actually be plugged into the calculator. We get 3920 watts. Power is in watts. Right. Now let's work out the second situation. So this is when this is lifting the crate. Okay, in the second situation, so we know that power is equal to the rate at which work is done. Work is equal to displacement is equal to force the displacement x cos of theta all over change in time. But in case 2, the block is stationary, so the displacement is 0. That means no work is done, therefore no power is done. So we can say no work, therefore no power. Actually, we say no displacement, which implies no work, and therefore there's no power. So that's how you do this type of question. You just write down the different types of formulas, and then it's just quite straightforward. Once you have the given information, just apply the values. So when the forklift lifts the object, lifts the crate, then power is 3920 watts, and when the forklift is stationary, then no power is exerted, right, or expended. Let's just do one more example just to get used to it. This one here is from a past paper. I think it's from September of 2014, one of the papers. It's been adapted for this question, right? So usually these sort of questions follow one after the other, so you need to calculate one to calculate two, and then it follows on like that. But yeah, so here it goes. It says a windmill is used on a farm to pump out water for a well that is 37 meters deep. The water flows past point A. So there's point A. Point A is right here. Point A. Past point A. The water was 37 meters above the well to the dam with a constant velocity of 3. This should be 3 meters per second. Apologies for that. This should be. Let's make this in black. It should be 3 meters per second. Right. The first question asks you, how much energy is necessary to pump 100 kg of water out of the well to point A? So, let's just calculate. Let's just write out. We've been given height, h is equal to 37 meters, and we've been given a velocity equal to 3 meters per second. We're given a mass equal to 100 kg. Right, so what would you do in this sort of situation? I mean, you're required to calculate energy. So what formula do we have to calculate energy? Energy is the work done, right? And you'll give an answer in joules. So what formula that involves height, mass, velocity? It's the formula to calculate work for the non-conservative force. So work done on energy expended by non-conservative force will be the change in the kinetic energy plus the change in the potential energy. And yeah, so if you think of it that way, then this will be the final height, this will be the initial velocity, and we know that height initial is equal to 0 if you take the ground to be 0, and we also know that initial velocity, sorry, this will be final velocity right here. We also know that the initial velocity will be 0 because the water is in the well. So like, the water is in the dam, it's stationary. So yeah, so we have all of the requirements to calculate this. So we can just basically substitute or simplify. So this is half m velocity final squared minus velocity initial squared plus mass times gravity h height final minus height initial. Right. Now we just have to plug in the necessary values, and we get that this is half. The mass is 100 kgs. The final velocity is 3 squared minus 0. And this will be plus again 100. Into a 9.8. And the height is 37. If you plug it into a calculator, we're going to get a value of 36,710 joules. Now I'll give you about 4 marks. This question I think was allocated 4 marks. So it's quite straightforward and to the point. Okay. Next question is a follow-up. What is the maximum power that the windmill must produce to pump 100 kgs of water per minute? Okay, what is power? Power is just the rate at which work is done. Okay. So we just calculated the amount of work done. So the amount of work done we calculated to be 36,710. And the amount of time, it says 100 kg, so it's the same as the previous question. That's why we can use the previous amount of work done per minute. So it's not going to be, so in 1 minute is equal to 60 seconds. So it's just going to be 60 here, because that's a rate at which it's done per second. So the amount of power will be 611.8 watts. Remember, power is in watts. And that's about 3 marks. You get 1 mark for the formula, 1 mark for substitution, and 1 mark for the final answer. It's quite straightforward. Right. let's move on now. Here's some just theory questions, some general knowledge. You can't really be tested much. I'll just give you an example. I mean, you will be tested like this, but it's common sense, right? Will the petrol water pump be able to produce the required water? Right, I missed out something here, right? So they actually suggested a 0.5 kilowatt. So the farmer wants to buy a farmer wants to buy a 0.5 kilowatt generator. Right, that information is supposed to be given. Will the petrol water pump, it's a pump, right? It's a pump actually, pump. Will it be able to produce the required power? So he wants to buy 0.5 kilowatts, that's equal to 500 watts. But the minimum that we just calculated that we need, or the maximum power, we need something that's over 611. So 500 watts is less than 611. Therefore, no. The first answer is no. It will not be able to produce the required power. So that's one thing. And the next question is, why would you advise the farmer to rather use a windmill instead of a petrol water pump? Now, you should know this by now, that climate change is a big thing. And petrol is not a renewable resource, but wind is. Therefore, you could advise the farmer to use windmill because it's more environmentally friendly. Yeah, so that's pretty much it. That's what you'd say. You'd say something like, the windmill is more environmentally friendly. Right. So it's something quite straightforward like that. These answers don't have to be, there's no set answer a lot of the time, but as long as it's reasonable, you will get the marks. So that's about it. Just learn the formulas and how to identify, and make sure you substitute the right values. That's about it. Thanks guys.